Hello, this is the first part of a two-part lesson on congruent triangles. The learning goals for this lesson are: understand the corresponding parts of congruent triangles are congruent, or CPCTC property, and also understand the triangle congruence postulates, SAS or side-side-side, SAS or side-angle-side, and ASA or angle-side-angle. Congruent triangles. Two shapes are congruent if they have the same size and shape. We have a triangle here, ABC. We're going to label the sides with tick marks. Different number of tick marks indicate different side lengths. So AB will have a different length measure than BC and than CA. Now we're going to label the angles with arc marks. Different number of arc marks indicate different angle measurements. So angle A has a different number of degrees than angle B and than angle C. Now we're going to take this triangle ABC and we're going to duplicate, basically copy and paste. And we're going to change its orientation. Now that we duplicated this triangle, we're going to relabel the vertices letters. So A is going to be relabeled to D, B is going to be relabeled to E, and C is going to be relabeled to F. Even after changing the vertices letters, the triangles are still congruent. Okay? So if we move this triangle and we put it on top of this, they will perfectly overlap. They are still congruent. Now we will erase the angle arc marks. These arc marks, we're going to erase them. So we can still identify the corresponding angles as they are opposite to corresponding sides. So the purpose of erasing these arc marks is to see how can we identify them if they are not labeled. So we're going to start labeling or writing what angle corresponds to what angle in the first triangle versus the second triangle. So angle A, this angle here, is opposite to this side with two tick marks. Therefore, angle A corresponds to angle D, which is also opposite to this side with two tick marks. Therefore, we can say that angle A and angle D are corresponding angles. And corresponding angles, according to this property, are congruent. They will measure the same. So angle A and angle D are congruent. Now, angle B, which is opposite to the side with three tick marks, corresponds to angle E, which is also opposite to this side with three tick marks. Therefore, angle B is congruent to angle E, because both of them are corresponding, therefore they are congruent. Angle C here is opposite to the side with one tick mark. Therefore, angle C will be corresponding to angle F, which is also opposite to the side with one tick mark. Therefore, C and F are congruent because they are corresponding to each other. So we can identify corresponding angles in two congruent triangles by looking at their sides. So this side and this side are congruent, therefore the opposite angles are also going to be congruent and corresponding. Okay, now instead of erasing the angle marks, we're going to erase the tick marks in these two triangles. So even though we erase the tick marks, we can still identify the corresponding sides as they are opposite to corresponding angles. So let's identify the corresponding sides. Side AB, which is this one here, is opposite to angle C, which has 3 arc marks. So in this triangle, we identify the angle with 3 arc marks. And we can see that DE is going to be opposite to that angle. Therefore, AB and DE are going to be corresponding and also congruent. Now, we label them with one tick mark. Side BC, which is this side here, is opposite to the angle with one arc mark in this triangle. So in this triangle, the side that is opposite to the angle with one arc mark would be EF. So EF is opposite to this angle with one arc mark. Therefore, EF and BC are corresponding. So BC is congruent with EF because they are corresponding. Now, finally, well, we're going to label each of these sides with 2 tick marks because they are congruent. Finally, side CA, which is this side here, is opposite to this angle B, which has 2 arc marks. So in the other triangle, in the congruent triangle, we identify the angle with 2 arc marks, which is angle E, and we notice that the opposite side is DF. So CA is corresponding with DF, and therefore they are congruent. So again, every time we need to identify congruent sides in 2 congruent triangles, we use the angles and the opposite sides to those angles as a reference. We're going to put 3 tick marks to show that this side and this side are congruent. Okay, now that we finished that property of corresponding parts of congruent triangles are congruent, or the CPCTC property, we're going to go into the first postulate of triangle congruency. The first postulate of triangle congruency is the side-side-side, or SSS. And this postulate says that if 3 sides in one triangle are congruent to 3 sides in another triangle, then the triangles are congruent. So here we have 2 triangles, and we say if AB, side AB, is congruent to side DE, and side BC is congruent to side EF, and side CA is congruent to side DF, then triangle ABC will be congruent to triangle DEF. Okay? So if the 3 sides are congruent to other 3 sides of this other triangle, then we can conclude that the two triangles are congruent. That's the first postulate, psi, psi, psi. Okay, so now that we understand this postulate of psi, 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 we're going to see if we can prove it wrong somehow. So we have a triangle ABC here, and the sides of this triangle will measure 4 and 5 and 6 in this example. We're going to label side AC with red and the side BC with green. And we're going to duplicate this triangle. Now, the idea is to answer this question. Is there a way to create a triangle with the sides 5, 6, and 4, but different angles? So basically a triangle with the same sides, but not congruent to the original one. So we're trying to challenge the postulate. We're trying to see if it's possible to have a triangle with the same sides as this, 5, 6, and 4, but with different angles. Remember, the condition for two triangles to be congruent is to have the same sides and also the same angles. If we are able to draw a triangle with the same sides, but at least one angle measuring differently from the first one, then we can prove this postulate wrong. But if that's not possible, then this postulate is right. So let's see if it's possible to modify, let's say, angle C and still keep the same sides lengths, the same lengths of the three sides. So if we rotate this side here, we change this angle C, we make it larger, but we also increase this side here. Side AB won't be 4 anymore. So that won't work. If we want to challenge this postulate by making this angle bigger, we're also modifying the side. So that didn't prove the postulate wrong. The postulate is still right. Now, if we change this angle and make it smaller, AB will also become shorter than 4. So we can see that modifying an angle will modify at least one side. Therefore, the answer to this question is no. By rotating AC, we realize that if the angle between AC and CB, this angle C, changes, the side AB also changes in length. So this postulate is correct. If two triangles share the same side lengths, therefore they are going to be congruent. Their angles are also going to be the same. Okay, so now we're going to explain the second triangle congruency postulate, or the side angle psi postulate. This postulate says that if two sides in one triangle and the angle between them are congruent to the corresponding sides and angle of another triangle, then the triangles are congruent. Basically, here we have two triangles, ABC, DEF. We're going to say if AB, side AB in this triangle, which is labeled with one tick mark and also with red, is congruent to side DE, which we label exactly the same as this one. And also if BC, which we label with two tick marks and with this purple color, is congruent to side EF, which we're going to label exactly the same as this BC side. And also, if angle B, which is labeled with two marks, two arc marks, is congruent to angle E, which is labeled the same, then the two triangles, ABC and DEF, are congruent. Okay, so basically if this side and this side are congruent to these two sides, and the angle in between these two sides is also congruent to this angle, then the two triangles have to be congruent. Okay, so now we're going to try to challenge this postulate to see if it's always correct. For that, we're going to create a triangle with sides 4, 5, and 6, and the angle in between this side 4 and this side 5 is going to be 83 degrees. Now, if we draw two segments with sides 4 and 5 and the angle 83 degrees in between them, like this, then if this postulate is correct, the segment in between these 2 points here, right, has to be 6. So yes, if we do that, if we draw these two sides, 4 and 5, and the angle in between them 83, the third segment, this side of the triangle, has to be 6, right? There is no way that we can draw a 4 and a 5 and 83 degrees in between and generate a segment in between these 2 points that is going to be different than 6. You can do the experiment yourself, but it's kind of obvious that this side has to be the same as this side, because this is kind of this is like a frame that cannot change. The angle cannot change, therefore this distance can also not change. So yeah, I think this postulate cannot be challenged, right? It's kind of self-evident. Now let's analyze the last triangle congruency postulate, the angle side angle, or ASA. So we have two triangles here, ABC and DEF. Now if angle A, this angle here, is congruent with angle D, and angle B is congruent with angle E, and the side in between the two angles, side AB, is congruent with side DE, and we're going to put a tick mark there to also show congruency between these two sides, we can say that ABC, triangle ABC, is congruent to triangle DEF. Okay, so again, this is called angle side angle because we have one angle, one side, and one angle that is congruent to one side, one angle, one side, and one angle on the other triangle. So angle side angle congruent to angle side angle. In this case, the side is in between the two congruent angles. Okay? Okay, so now we are going to try to make sense of this postulate, angle side angle, to see if it makes sense that it's always going to be true. So for that purpose, we have two segments here, BA, ED, which are congruent, both measure 4. And we're going to draw additional segments, as you see, with the same angle here. So we draw this segment BC with one angle, that is going to be the same angle here. And we draw here the segment EF. And we draw a second segment on both triangles, because there are triangles now, with the same fixed angles on both sides. So we can see that if we do that, right, if we measure one angle here and the same angle here, and we draw this segment, and we do the same for the second segment, we measure another angle, and we write, or we use the same angle here, and we draw the same corresponding segment. In both cases, those two segments are going to intersect at the same distance from the red segment. Okay, so this is a corresponding distance, right? This distance and this distance are the same. And the black segment and the blue segment are also going to be measuring the same. Okay, so yeah, basically, if we have an angle, a side and an angle, and it's the same on the other triangle, we know that the other two sides are going to be congruent to each other as well, because of the corresponding distances are going to be basically the same. Now, in this slide here, we summarize all three congruency postulates we have seen so far for triangles. So the first one is the psi, SSS, which says that if two triangles share the same three sides, right? Here we see that this one has three sides that are congruent to these three sides, then the two triangles are congruent. The second one is the side angle psi, or SAS, side angle psi, which says if we have two triangles that have two sides in common, so this side congruent to this side, and this side here congruent to this side, and the angle in between those two congruent sides are also congruent between triangles, then we can say that both triangles are congruent to each other. And the final postulate that we saw today is the angle side angle, or ASA, which says that if we have a common segment, a common side in two triangles, right? This side is congruent to this side, and the two angles that are on each side, right, flanking this side, are also congruent between triangles, then we can say that those two triangles are going to be congruent. Again, it's angle, side, angle, angle, side, angle. Okay? Okay, so now we have to emphasize something important when we label triangles or when we compare triangles for congruency. Here we have two congruent triangles, triangle ABC and DEF. Okay? And we say triangle ABC is congruent to triangle DEF. The order of these letters is very important. Okay, if we change the order of the letters, let's say we say ACB instead of ABC, then these two triangles will no longer be congruent. Okay, let's see what I mean. Here, these two triangles are properly labeled. So if I go from A to B, this side, that will be congruent to DE. You see, both of them have one tick mark. We know that this side and this side are congruent to each other. Now, if we label BC here, B to C, that has to be congruent to the side EF. You see, both these sides have two tick marks. They are congruent. Now, finally, if we label CA, side CA, that has to be congruent to the side FD. Both of these sides have three tick marks. We know they are congruent. So you see, the order is important. AB has to be congruent to DE. BC, the side BC, has to be congruent to the side EF. And the side CA has to be congruent to the side FD. Okay, it's very important, and the order of the letters is important when you establish congruency. So if we switch F and E in the second triangle, in this triangle here, the triangles won't be congruent anymore. Let's show why. You see, we're switching those two letters, F and E. Now, AB won't be congruent to DF anymore. right? This side and this side are not congruent because this side has 1 tick mark and DF has 3 tick marks. Therefore, these two triangles are not going to be congruent. Also, CA, this side here, is not congruent to ED, this side here. This one has 3 tick marks. This one has 1 tick mark. Therefore, these two sides are not congruent. So it's very important to follow the right order when working with congruent triangles. Okay, if you switch these letters, the triangles will no longer be congruent. So ABC is congruent to DEF, not to DFE. Again, changing the order of the letters breaks the congruency. Okay. Well, that's all for this first part. Thank you very much for the attention.